Now that is very clear, right? So when you take the key and the information ABC123, you know you're not getting them as your final answer because your final answer is that printed solution piece. But where is it residing? It's there, right, in the passengers compartment of my red Toyota Camry car, not any other Camry car. So how do you know it's mine? Well, you got the key. Well, the key is beside the point because it's physical. But the most important information is ABC123, the car plate number. So you know exactly where to go. You are not confused. It's very unique and it is very expeditious because I'm not going to say, you know, that car with a bump on the left side rear and a scratch on the front side right, just go check and find out. You're not going to appreciate that descriptive description, right? You're going to much uh, more appreciative of a quick, unique pointer, which is the car number plate. So, coming back to our example here, same thing. When we say assign to list of ints the the value, which is a structured list contained in the numbers, Python will look at numbers, sees that it contains a structured type, it's a list, and immediately activates a storage of the pointer into list of ints. So in other words, list of ints doesn't have a copy of the entire list. So there are no two copies of 2, 3, 4, 5, 6, 7, 8, 9 lists inside the memory space. There's only one. Okay. Now, why do we do that? Because remember that I'm just giving you an illustration. There are only how many? Nine, eight numbers here. But if this is 1 million numbers, and if we pass this as a copy, so upon calling a function like detect prime, local variable list of ints, but I call detect prime with a list of numbers that is 1 million strong, right? So there are 1 million numbers inside. What happens if Python performs a copy version of assignment instead of expeditious pointer assignment? Oh, that would be super slow, right? Because sometimes we do need a copy, but not in this case. We just need the function detect prime to read out the integers and then process them. So it would be great if we just have a pointer and ask detect prime to kind of like share the content stored elsewhere, but I give you the pointer to look at that. However, I'm going to refer to that value, that list, internally inside my function here as list of ints. I don't want to have it confusingly also called numbers. You see, so programming logic is very clear here. I'm always referring to list of ints. If I sort of outsource this function development to my group mates never have to check with me, can I use list of ints as my local variables and so on and so forth again, right? So um, to summarize, whenever it is structured type, here I use list, but it could have been a set, it could have been a dictionary, it could have been a class, all right? And all these are mutable, as you notice. I didn't say tuple, all right? So all these are mutable, uh, what is it? Mutable structure types. Now for tuple, it is also a structure type. It is not an exception. Also, a pointer is being stored, all right? But we cannot be writing up to it because tuple is supposed to be the non-mutable, cannot be changed type of lists. So it's a list, behaves, smells, works, everything like list, except you cannot assign value to it, change the value to it, increase the length, delete the value, you cannot do anything. Immutable is what we say. So all structured types will be passed by reference. That's what we say, passed by a reference into the function. Okay, so pass by reference. And that is not the only thing you need to know. What is much more importantly is the mutability of structured parameter values. So what does that mean? When we pass a integer, like earlier on here, we know that if we assign I inside, if we put I equals to 2, I equals to 3, we will change a local variable value. And when we return, since return doesn't return anything about I, well, the effects on assigning any values to I, it will be gone, will be lost. So in some sense, it has no impact at all to the global behavior. Not so, however, when we passed a structured type, especially a mutable structure type, into a function. Remember, it is efficient assignment. So Python is going to store a pointer to the same huge, remember, huge list value. So it's not going to duplicate that, so that when you change it here, you're not changing it there, right? And it's kind of safe, but then it's very inefficient, especially when the size of it becomes larger and larger. So what happens is when we do need to mutate, that means to change, increase, insert new ones, delete old ones, modify existing ones. When we need to change any of the components inside the structured value, like this, list of ints, square bracket, the ith position, assign it to dash. We know originally is integer, but now change to a string, right? Showing a dash. In other words, it's our way of saying canceling out the number like this. If it is not prime, then cancel it out, something like that, right? So that's what we have in mind that we want to design. And then when it comes down to programming, we need to mutate or change the ith position of the input list of integers, which is a structure type. So now, if you input tuple, it's going to break because you're not supposed to change tuple. If you input a list of integers like what we do here, we generate the list of integers, numbers, then we pass the numbers in. So first thing first, Python will go and find, is there a function called detect prime, right? If you never define it, error. So we have defined it. And then it says, how many parameters does detect prime require, insist? Well, it insists on one, so we supply list inside. And so here, Python performs what is invisible to us, something like this. It performs a list of ints equal to numbers. Okay, so let's slow down and freeze frame what this means. It performs an equivalent of list of ints, local variable, equal to numbers, whichever value is stored in the global variable numbers. Now, remember, Python performs an efficient assignment for structure types. So in other words, it's going to realize that numbers has got a list. And so it's going to create a pointer to point at it like the car number plate and store just the car number plate into list of ints. So when we need to reference the list of ints, like enumerating it, reading it out, it's going to read list of ints. Oh, I get a pointer, and this pointer points me to the global variable numbers value, and which is a list, and then I access the ith component of it. So it's going to jump a few times at electronic speed, no doubt. So we hardly detect any slowness in that, and it's considered efficient by all programmers. So that's very fast and undetectable. But then comes to this line here, list of ints of I equals to dash. Aha, here we are going to follow the same way Python does things, and which is to say, I want to access list of ints on the left-hand side of the assignment, which means I'm going to store into it. Okay, now because list of ints is a pointer, it's going to look at the position or the space occupied by the global variable numbers list. And looking at the ith position, going to like 4 here, is going to reset it to a dash. So when we ask, what is the numbers? Remember, we call detect prime without catching the return value. In fact, the detect prime doesn't have a return statement, so it doesn't return anything. But that doesn't contradict what we said earlier on, that a function always returns something. We'll see. All right, we'll try that out. So here we're calling detect prime without catching the return value because there's none. And we just simply look at the global numbers. It's like call define numbers, call detect prime. We didn't do anything to numbers, and then look at numbers. Now, if we didn't look through the body content of detect prime, it could be surprising, huh? We should be getting 2, 3, 4, 5, 6 again, right? But no, because detect prime actually got a pointer to the global variable's value. And so by modifying what seems to be a local variable's modification, it is actually indirectly modifying the global variable's content when it is structured type. So remember structure type, list, tuple, set, dictionary, and class. Right? So except we don't modify tuple. So let's try this out and see that it is working as we say, right? So I'm just copying and pasting. And detect prime, if not is prime. So we need, well, I would actually go back to here because we need is prime upstairs here. So it will keep it there. So it will rerun again, finding all primes because that's very fast. Let's just let it run. Put a separator here. And then we define detect prime. And now it's able to check, right? For each of the integer listed in list of ints, is it prime? And if it's not a prime, then cancel it out by assigning a dash string into the list position. But which list? Well, there is only one list in the global space, right? So let's try and run this and see. So originally, this numbers is printed here. Then we call detect primes, which if you see this line 31 here, you will find that it actually modifies the content. Okay, and so which content? It is the numbers content. But here, be careful now, right? I have been keep on emphasizing that numbers is a structure type. That's why it's a list. It's got internal structure and content. You can touch the content, but you're not changing the list, right? It's still a list. I keep emphasizing that so that you, as a beginner, you're not going to be confused with a list being like a scalar type. Like you created a copy of it, a list, and when you call detect prime numbers, a copy of it is being passed inside. And so whatever you modify shouldn't affect the original numbers, isn't it? Yeah, that's true if you copy the list of numbers. But Python chooses to pass by reference. Pass by reference. So long as the value in the caller, this is the caller. The caller supplies a value which has a structured type, like a list here, then Python will perform additional steps. It creates a pointer, and then that pointer is assigned to the list of ints. And from there on, everything that we refer to, assign to list of ints, modify against list of ints, will be done directly onto the value, the list value stored in the global numbers. This is how it works. Yeah, okay. So even though we pass the list of values, it is the original list that is being modified, not a copy of the list. Okay, let's check.